What is up, guys? DevCode here. So we kind of left off where we were writing all of our functions for our error management system, so we're just going to pick up from there. So for our print error function, basically all we need to do is simply check for whether or not it's a warning. And here's the difference between us printing warnings versus us printing errors to the console. So if it's a warning, we're going to do our standard print our file name, colon, what line and column we're on, and then we're just going to say warning. And for this language, I haven't created official documentation for our errors and the different types of errors you can have, but basically warnings are going to start with the number S60 and errors are going to start with the number S80. And those are just values to basically differentiate between each error because each error has its own unique ID. And then finally, we just need to print out whatever our error is, and that's it. Now, down here is where it gets a little interesting. So if you guys have ever seen in a programming language where, let's say I make a mistake right here, so I'm going to put an and here. If I try to compile this, so now you can compare pretty much with what our language is doing versus what a compiler that's widely used is doing. We're kind of doing the same thing. So we have our file name. This has our file name here in blue. And then we have our colon, our line, colon, column. We have whether or not it's a warning on error. In this case, this is an error. And then you have your message immediately afterwards. So pretty much the same thing. But then down here, we also want to tell the user and show them specifically where the error happened. So since we know the line and the column of our error, what we're going to do is we're going to enter a new line, then we're going to output basically the line that error occurred on. So in this case, we would be printing out cout and all this other stuff here. And then we enter a new line again, and we want to basically put an arrow to where exactly that error happened. So that's where the column comes in handy. So we're going to just basically put a bunch of spaces, and then once we eventually get to the column, then we're going to put that error right there at that specific point, so that way the user knows exactly where the error happened. So the next function that we need to do is we need to be able to get the errors based on a list that we pass in. So the first thing we need to do is create a string stream called error list, and then we're going to have a for loop of parse errors. So I've added the rest of the code, and basically what this does is it does exactly the same thing that we're doing up here, but instead of printing out your text to a console stream or an O stream, you're just going to print it out to a string stream, and then all we have to do is return error list at the end. Alright, so now that we have a way to where we can get our errors and print our errors, we need to be able to create a solid function to print our errors based on certain criteria. So we're going to create our void error manager's print errors function. And basically what this function will do is this function will print out errors based on some of the settings that we passed into our compiler. So first thing we need to check is if our compiler code is printing out data as is. And the reason why we want to check this is we really don't want to be printing anything to the console if we already know that this flag is not going to be storing any of our data anyway. Next, we need to check to see if we have any errors. And if we have errors, then we can finally check to see if we have our aggressive error reporting flag. And if we have our aggressive error reporting flag, we can just print out every single possible error that we've ever found. Otherwise, we can just print out our groomed errors. So in this case, we would just cout get errors, and we're going to pass in our unfiltered errors. And then if we don't have error aggressive reporting enabled, then we're just going to output our regular errors, so our groomed errors. Finally, we just want to output any warnings that we have, so we can say get errors and then print out our warnings. And we don't care in this case whether or not we had any errors at all, because again, they're just warnings, they're not harmful. So if the user did something to have a warning, it won't necessarily prevent their code from compiling, it'll just be printed to the console. And again, if we have our as is flag set to enabled, even when we're storing warnings, we're also going to be printing those directly to the console as well. Warnings aren't excluded from when we're reporting our errors. Next, we're going to need to have a function so that we can create errors in our compiler. So in this case, we'll be passing in our token entity, and we'll have to get our information from there. So before we go on to creating this function, we're actually going to go and create our token entity class. So that way we can have all of our functions available so we don't keep getting compiler errors. So our token entity class is going to need to have a couple different types of tokens so that way we can process them in our language. And basically what a token entity ID is this is essentially not really defined as a token, but this is more of a high-level definition of a token. So we have something like a token could be an identifier, a native type, a type identifier, a integer literal, hex literal. We'll get to what some of these mean later. Basically, the reason why we need this is because we're going to need to know a little bit more information about our token. That way we can process each of our tokens a lot faster than we normally would be able to. So the first thing we're going to do is create our variables for what our token entity class is going to have. We're of course going to need to know what line our token is a part of, what column it's a part of. Then we're going to need to know the token entity ID, or the high-level version of what this token is. Then we're also going to need to know the token type. So whether it's a letter, a single number, or something like that. And then finally we're going to need to know, of course, what is the actual token. So what's the string value of that token when it was processed. So now that we have that, we can start creating our constructors for our token entity class. So the first constructor is going to just take all of the values that we can pass in and use it. Next, we're going to have an empty constructor, which is basically just going to initialize everything. We're also going to need a destructor, and this is basically going to set the information in this token to nothing. That way, when it gets destroyed, we don't have to worry about us leaking memory based on this string object. Next, we're going to have an operator overload, which is going to compare this structure or this class against a token entity ID. That way we don't have to extract the value out of here by calling some function. It'll just look much cleaner in the code. Next, we're going to have an operator equals to assign a token entity to itself. Next, we're going to have another operator overload, but instead of comparing to token entity ID, we're going to compare to token type. Next, we're going to have an equals to see if a token is equal to another token. And then finally, we're going to have a final compare, which is going to compare whether or not a token is not equal to a string. And basically all these operator overload functions or like I said before, they're just really quick shortcuts, and they're really handy to use when we're doing comparisons and stuff like that. So now that we have the helper functions and constructors out of the way, now we need to start creating the actual functions to get access to this data, considering that it's private. So first we're going to need to be able to get the ID of our token entity. Next, we're going to need to be able to set the ID. Next, we're going to need to be able to get the token of our token entity. Next, we need the column, the line, whether or not this token entity is single. And what this basically is going to do is this is going to check whether or not our token entity is a single entity. So if I confused some of you guys earlier about why do we need to have a token type and why do we also need to have a token entity ID, even though I did say that this was used so that way we can have more information about our token, the reason why I split them up is because you can either have a token that is an identifier or a hex literal or an integer literal, or you can have just a single token. And basically what that's going to do is that's going to say, okay, since we have a single token, then that single token can be a number, a letter, an underscore, any one of these tokens here, a math symbol or something like that. So if our token is single, then we know that we can't reference what type of token it is from this enum list. We have to go to the other one. So I've created all the functions here, and it's very simple. All you're literally doing is returning the actual variable that's within the class for each of these functions. So for getID, you're returning ID. Setting ID, you're just setting the ID equal to something. And all these getter functions are just simply returning the value for each of them. I also forgot to mention that you're also going to need to be able to get the token type as well. That's an additional function that I have here. So now when we go here, that red value is no longer there. All right, so now that we have what our token entity class is, now we should no longer be getting errors for this class. So now we can start writing out how to create a new error in our compiler. So the first thing that we're going to need is we're going to need to create a key pair based on the type of error that we're dealing with. So we're going to call getErrorById, to which we haven't created yet. But basically what that's going to do is we're going to pass in an error type. So let's say we have unexpected symbol. We're going to pass in that error type, and getErrorId is going to construct a key pair that's going to hold that error type and the string of what that message is going to say. So if we scroll up here, we can actually see that our error for unexpected symbol already has some pre-canned text. So if we were going to complain about this, we would just pull out the text that's right here and report it to the console. Next, we're going to need to create our makeshift parse error. So we're going to create just a simple error here, which is going to have our key pair for the type of error it is. We're going to have our token entity, which we're going to pass in, and then any extra comments that we were going to have. So like I said before, we were just going to complain about an unexpected symbol. Well, you can't just say that and not tell the user what symbol was unexpected. So in this case, we might have some extra comments saying unexpected symbol semicolon or something like that added to our error. Next, we're going to need to say what our last error was. And we're going to check this Boolean here, cm, which is something that is in our actual class. And the main reason why we're checking this is because when we get into our functions called pass and fail, basically as we're processing our language, let's say in our parser we were processing some type of expression and we thought that what we were processing was an expression. Well, what we're going to do is we're going to have to enable what's called an error check mode. If in that expression that we are parsing we find out that it was actually in fact an expression, then what we can do is we can end up failing our error check and say that basically if there were any errors found, we want to report those to the error management system. If there weren't any errors, then we just proceed as normal. But if we found out that our expression that we were parsing wasn't in fact an expression and it was something else, then what we can do is we can pass the error check mode and basically tell the compiler, hey, if you found any errors that were queued up to be reported, we essentially want you to dump those errors out because we're going to allow this error checking to pass for now because we realized that those errors that we reported were pointless. So now if we go back here, basically what this is going to do is this is going to look at our last checked error. So whatever was the last error that was being queued up, we want to set that as our last error. If we're not queuing up any errors, then we just want to set whatever our last error was in the actual error management system. Next, we need to check if whether or not we should report any errors that we find. So we're going to pass here in the should report function, we're going to pass a null, whatever our last error was, and then we're going to pass our error that we created based on the data that we passed in the parameters. So if our compiler has determined based on this function whether or not we should report it, the first thing we're going to need to do is we're going to need to check to see if we're reporting errors as is. And if we're reporting an error as is, we literally are going to do nothing but print out whatever the error is. So we're going to take our error here that was created up here and just print it directly to the console. Otherwise, if we're in check mode or error check mode, and I know this variable is probably a bad name, I just kind of over abbreviated this variable here. So you guys can name it whatever you want, but basically this is just a Boolean that says, are we in error check mode? And if we're in error check mode, basically we want to just push back our error. First thing we need to do is we need to get our possible error list, the list that we have in our cache that hasn't yet been reported, but we're just queuing up a bunch of errors. And then we want to add this new error to that list. Next, we want to set our last checked error to whatever our error is, so that way if we're in the error check mode, we can go based off of that. And basically what we need this for is just as how we don't want to report errors in our error management system while we're directly storing them in memory, we also don't want to complain about the same errors over and over again, even when we're queuing them up. So no matter what our compiler is doing, whether we're queuing up errors or not, we still want to maintain the integrity of not constantly reporting the same errors over again. Next, we just want to return 1. Alright, so now this is where we get to the part to where we actually start complaining about our errors as they're going. So if we've decided that we should report the error and we're not printing errors as is, and we're not also queuing up any errors, what we're going to do is we're going to say, okay, we have found officially any errors. So we're going to set error to true. That way our compiler knows we've actually stored real errors that we've found in our error management system. Next, what we need to do is we need to push back this error in our groomed errors, and this will only be set if our error management system decides whether or not we should even report this error in the first place. Next, we're also going to report our unfiltered errors. After that, we want to store what our last error was. Since we're not in error check mode or caching our errors, we're actually processing them. So we're going to set our last error. And make sure you put this reference, because otherwise you'll be setting this local variable up here. And finally, we just want to return 1. So now what happens if our compiler decides that we shouldn't report this error? Because if we're going to have unfiltered errors basically store every single error that's been ever found, but if our compiler suddenly decides that this error that we're complaining about shouldn't be reported, we just need to have an else statement here saying we want to set unfiltered errors to whatever that error is. And then finally, we want to return 0. This means that if it returns 0, we didn't report any errors at all. If it returns 1, that means we did report an error or we cached an error. Alright, next we're going to actually start writing the logic for our compiler. So this is going to be the most important function in our error management system. This function is basically going to be the only thing dividing us and the error itself. So this function is going to have a huge if statement that's going to check a bunch of parameters to make sure that we absolutely have never reported this error before in our system. So the first thing we're going to need to check is we're going to need to check if our last reported error is not equal to our current error that we're reporting. So if our last error said unexpected symbol and this one also says unexpected symbol, and error is the physical string of the message that we're reporting, then we basically don't want to add that and we shouldn't report it. Next, we're also going to need to check whether or not our last error is not reported on the same line and it's also not reported on the same column. So we don't want to report errors that are specifically in the same position that our last error was also reported. Next, we're also going to need to check in this if statement whether or not our last error contains any text within this error in our last errors. And then, well, if you're thinking, well, if we're just simply basing off the error that we're currently reporting based off of our last error, then we most definitely will be reporting the same error over and over again. Well, that's why I also added another if statement to check, have we reported this error ever in the entire error reporting history? And I look at what errors we have reported in our groomed errors, not in our unfiltered errors. Next, we're going to need to have another set of if statements that are going to further check to absolutely make sure that this error was never reported. So first, we're going to check whether or not this token was not equal to null. Next, we're going to need to add a series of checks for if we pass in a token, we want to make sure that our token is single, whether it's a char literal, a string literal, or an integer literal. And then finally, we want to check the last error that we reported, and we want to see if we can find this token inside of that error. And the reason why I added this was because let's say we're complaining about an error on a specific token and it's a string literal, a char literal, or an integer literal, or something like that, then there are possibly some errors that we can complain about, such as an malformed integer literal or something like that, that we could be complaining about that specific token and report a different type of message and have two different type of errors completely, but they're complaining about the same thing. So basically, in our error reporting system, if we've gotten through this if statement, and if we have a token entity and we've gone through that if statement, and we've also ensured that that token entity is not in that message itself, then we'll just return whether or not that's true. Otherwise, if we have gotten through this if statement and our token is actually equal to null, then what we're going to do is just immediately return true, because we've gotten through pretty much every possible if check that we can do to ensure that we're not complaining about the same error. Otherwise, if we couldn't get through all of these different type of if checks, then we're just going to return false. Next, we are going to have should report warning. This is effectively exactly the same thing, only it's going to be used for warnings, and nothing is different here in terms of the if statements or the if checks. The same thing that we just talked about up here is the exact same thing down here. The only thing different is the name of the function. Alright, so we're nearly there. We're almost finished with our error management system. That way we can start getting into the really fun stuff, which is the tokenizer and the parser. So the next thing we need to do is we need to create another create new error function. And basically the purpose of this function is that we're going to pass in an error type in physically our line and column instead of just passing in a token entity. And this function is exactly the same. Nothing is different in this function. The only thing that's different is that instead of a token entity, we're just passing in our line and our column. Next, we're going to need to have a function called create new warning. Now this function is going to be slightly different, but pretty much the same concept. What we're going to do is we're going to say if warnings.size is greater than 0, we're going to set our last error based on the value in our warnings list. Otherwise, if we don't have an error, we're just going to do our basic check where we checked up here for create new error. Once we have our last error, all we need to do is just check to make sure if our size is equal to 0, or if we should report this warning, then we do our basic check. If we should print as is, then we print the error, and then we just basically set the warning directly here. Now, I'm not doing anything with unfiltered errors because it's not really an error, and every time we report an error, we shouldn't have duplicates because we do have this function called should report warning that's going to make sure that's not going to happen. So we can just have one type of list for our warnings here. Next, we're going to have getLine, and if you remember back when we were using our print error function, this is just going to get the physical line in our code. So what we're going to do is, as we're processing this, if we've reached the end of our lines, we're just going to print out or return end of file. Otherwise, we're just going to get the line here. Now, I know we haven't created our list class. We'll most likely do that in the next episode. It's basically just a helper class that's a little bit easier to use than stdlist. Next, we have our getErrorById function, and what that's going to do is that's going to return the type of error that we have in our list. So we're literally just going to access this predefined errors list and just get the error type at the index of that error. Next, we have hasErrors. And what this is going to do is this is going to check to see whether or not we have any errors at all. And if we do, just make sure that our unfiltered errors is not equal to 0. Next, we're getting into the parts where we can start to check errors and not report them. So this enable error check mode is all it's going to do is it's going to set error check mode to true, and it's going to add the possible error list that we're going to be caching. Next, we have a list of parse errors. So we're going to get our possible error list. We're just going to get basically the last element in the list. Also, guys, I know I'm moving pretty fast, but if you guys have any questions about something that I maybe went over or something you didn't understand, please feel free to just put the questions in the comment section below, and I'll try to answer it as fast as I can. All right, next we have remove possible error list. And what that's going to do is that's going to just remove the last cached list of errors. So we're going to get that value, we're going to clear it because it's going to have a bunch of classes in here. So we're going to clear it and then delete the list, pop it back from the list, and decrement the TE cursor. Basically, if our TE cursor is less than 0, then we want to set our error check mode to false. That way we know every time we call enable error check mode, because this function may be called recursively, we just want to make sure that are we still checking errors. And if you guys are really confused about this error check mode and caching errors but not really reporting them, I'll get to all of that in the parser. It's a little bit confusing, but it'll be easier further we get into this compiler. Next, we have add possible error list. All we're going to do is just push back a new list of parse errors and increment the TE cursor. Okay, so this is where it gets interesting. So now we have our fail function in our error manager. So what we're going to do is we're going to say if we're going to fail, we're going to look at our possible errors list, and if it's greater than 0, what we're going to do is we're going to go in each of these errors and we're going to check whether or not we should report them, because we can't just savagely dump all of our cached errors into our error list. What we're going to do is we're going to still check to see if we should report those errors, and if so, then we push it to our errors list and go from there. Then we want to check to see if our cursor, our TE cursor, is less than 0, less than or equal to 0. And then if so, we want to set our last error that we officially reported to whatever our last checked error was. And then we just reset our last check error, and then we remove our last error list that we just reported. So basically what this function is going to do is as we're failing, let's say we've called this add possible errors list or enable check mode recursively twice. And let's say the first time we failed it. What we're going to do is we're going to add all of those elements here that we had cached up in our list, push those up into our error system, And then if we pass the second one, we're going to dump all of those errors and ignore them. Next, we have pass, and what this is going to do is this is just going to reset last checked error and remove our last error list. So whenever we pass an error cache, we're just going to dump that list and ignore it as if it never happened. Next, we want to make sure we free every single thing in our compiler. So the standard for my programming language and the way that I have allocating and deallocating objects, I normally have a free function which basically clears up any type of data that I need. So we're going to go here to parse error, and we're going to just create a simple free function, and all that's going to do is clear up this string here to make sure we're not leaking any memory. So we do have a couple of functions that we don't have yet, which we will add in a later episode, but basically what this does is this is a simple function that frees up each type of list that we have in here. And then we also want to delete all of our possible errors lists. We also want to free up the lists in there as well. And then we do some basic deletes on those lists, and that's it. Next, we want to check to see whether or not an error list has ever contained an error possible. And the way we do that is, if you remember back when we were checking whether or not we should report an error, and we check to see if we've ever reported this error possible, what we're going to do is we're going to pass in some type of arbitrary error list, and then we're going to pass in our error that we want to check against. And we're just going to jump through that list using a for statement and look at each single error that has been in that list to see if they're equal to what we're checking against. Next, we need to have a function called create new error. Basically, what this function is going to do is this is going to do exactly the same thing as all of our other error functions above, except the way that we get our line and column is by extracting it directly from this AST. Don't worry about any errors that we're having now, because we're going to be creating an abstract syntax tree and what that is very soon. Finally, we have our create new warning function. And this is also going to be exactly the same as our other create new warning, except the way we extract our line and column is through this AST. Alright, so I know that was a lot, but that's pretty much it for this video, and that effectively concludes our entire error management system. So we have all of the necessary functions that we need to properly process errors in our language. Coming the next episode, we're going to clear up some of these compiler errors that I know are a little bit annoying. So that way we can have fully compilable code so we can start to test our compiler as we go along. So I hope you guys enjoyed this video. Definitely like and subscribe if you guys like what you saw and you want to see more. Till next time, see you guys later.